Today we're embarking on a new section called exponential functions, and today we're going to understand and construct some geometric sequences. So go ahead and pause and write this down if you need to, and hit resume when you're ready. Here's a definition of a geometric sequence and an example and the definition of a common ratio. So go ahead and pause the video and write these down. If you remember, an arithmetic sequence is something where the common difference, not the common ratio, but the common difference, okay, it's added or subtracted. So between each of these terms, we're adding 2. And remember, this is going to be the first term, that's the second term, it's the third term, that's the fourth term, that's the fifth term. This is an arithmetic sequence because we're adding or subtracting. A geometric sequence is when we're multiplying, such as 3, 6. You expect it to go up to 9 because we would be adding 3, but this is where it differs from the arithmetic sequence, where we've now got, this is what we called the common difference. And now in a geometric sequence, we're calling it a common ratio. It's something we are multiplying or dividing by. So in each of these, again, this is the first term, the second term, the third, fourth, and the fifth term of the sequence. And the common ratio is what's happening every time. We're multiplying by 2. 3 times 2, 6 times 2 is 12, 12 times 2 is 24, 24 times 48. 24 times 2, sorry. So the common ratio is 2. We are multiplying by 2. So now it's your turn. Determine if these sequences are geometric or whether they're arithmetic. If it's geometric, state the common ratio. And if it's arithmetic, go ahead and state the common difference. Go ahead and do number 1 and resume the video when you're ready. Okay, the first one we're adding 2. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, and plus 2, and so on. We're just adding 2. This is an arithmetic sequence. Okay, go ahead and pause the video and try number 2. Is it arithmetic or geometric? Okay, the next one is geometric because we are multiplying by 3 every time. 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, 81 times 3 is 243. And again, the first term, second term, third, fourth, fifth, sixth terms in the sequence. This is a geometric sequence. Okay, go ahead and pause the video and do number 3. Okay, this next one we are dividing by 2, so it is also geometric. Now when we talk about the common ratio, it's something we need to multiply by. So technically when we divide by 2, we multiply by a half, and you could put it in fraction form or decimal form, which is 0.5. So we do it in terms of multiplying. So when we're dividing by 2, we're multiplying by a half or multiplying by 0.5. So this would be the first term, second term, third term, fourth term. The fifth term would be 0.75 because it is 1.5 divided by 2 or 1.5 times 0.5. Go ahead and pause and check out number 4. Is it geometric or arithmetic? And tell me what the common ratio is if it's geometric. Okay, number 4 is also geometric, and we're multiplying by a -2, so my common ratio would be -2. That's what I'm multiplying by. And remember, in a geometric sequence, we're going to always multiply by something. That's why when we divide it, we have to put it into fraction or decimal form. And again, 7 times -2 is -14. -14 times a -2 is 28. And then you have -56. The next one would be 112, and then that times -2 would be a -224. Now here's a perfect example of a geometric sequence in context. If somebody was bungee jumping off of a bridge, you'd go down and your first bounce would snap all the way back up here, then your second bounce would snap up to here, and then the third bounce would snap up to here, and your bounce would slowly down until you're just hanging by the end of the bungee cord. Now here's my picture of this, and then my little chart. The first bounce, which is going to be the first term in the sequence, was 200 feet. Second term, or second bounce, was 80. Third term was 32 feet. Now I want to try and find the what the fourth bounce would be and what the fifth bounce would be. Now to get my common ratio with this, I just am going to take, because you can see these are going down, so basically I'm dividing. So I need to find the ratio, and I'm going to put my 80 on top and my 200 on the bottom, and I'm going to calculate 80 divided by 200 equals 0.4. So my common ratio is equal to 0.4. So let's see, let's multiply 80 times 0.4. 80 times 0.4 equals 32. So to get my next term, I need to take this term, the previous term, and multiply it by 0.4. So 32 times 0.4 is going to give me 12.8. And then I take 12.8 and I multiply it by 0.4. Again, remember, we're dividing, but now I get 5.12. And notice these are going down exponentially. They're not going down in a pattern of minus 50 or minus 50. They're increasing at an exponential rate. And that's what we talk about in geometric sequences versus arithmetic. So now I'm going to show you how to write explicit and recursive formulas for a geometric sequence so that you can use them and apply what you already know to find specific numbers in the sequence. So go ahead and pause the video and write down these two formulas. The explicit formula, and I'll explain in a second, and then what we call the recursive formula. And I'll explain that here in a second with our last example of the bungee cord, using that for the context. So go ahead and hit pause, copy these two formulas down. They're important, you're going to need them, and then hit resume when you're ready. And just a bit of more notes. R is equal to the common ratio, as we just learned in the previous slides. And N here is going to be the term in the sequence. So using our example of the bungee cord, here was the first bounce, second bounce, third bounce. These are our terms. This is the first term in the sequence, the second term, the third term. My ratio, my common ratio, we already figured out was 0.4. So my N, or term in the sequence, but this is the first one, so N would be equal to 1. N would be equal to 2, N would be equal to 3. N is equal to the position or the number in the sequence that this represents. Go ahead and pause and write this down. So writing a recursive formula is the easiest thing to do, because every recursive formula, you just copy this first part for every single one. So you have f of n is equal to f of n minus 1, and then the only number we have to put in here is our common ratio. So using our bungee cord example, we've got our common ratio of 0.4. So for the recursive formula, the only thing we have to put in here is times, multiply 0.4. And then we just copy the rest of the formula for any term greater than or equal to 2. We write this for a recursive formula because for a recursive formula, they have to give you the f of 1. So we have to know what our f of 1 is. And we know that our first term is 200. So for a recursive formula, you write the f of 1. Here's our first step. Then our second step is to rewrite the formula only replacing the r. That's it. You just have to write in the first term and replace the r, and everything else looks like this, and you are done. This is what writing a recursive formula looks like. You just put in your r. You figure out your r, put it in, put your first term in, copy the rest of this down, and you're done. And we'll do a few examples here in a second. Before we get into the explicit formula, I just want you to notice something about the recursive formula. The green parts, the highlighted green parts, are the only things you substitute into the formula. Everything else stays the same. You don't mess with this n minus 1. You don't mess with this. You just write in what the first term is, what the common ratio is. That's it. Looks exactly like the formula, except you're replacing it with those two numbers. And let's contrast the explicit formula. In the explicit formula, we are going to replace the f of 1 just like that one, over here. We're gonna put our number in. However, we put a number in for f of 1, where this one we left this alone, or we just wrote the number out here. This one we actually are going to replace it. And then we're also going to replace the r. Okay? So for the explicit formula here, we write f of n is equal to, f of 1 means first term. This means we need to put the first term in here, the actual first term. So the actual first term, which we know from this one, or we know from our chart up here, is 200. We put the actual number in this time. We put it into the formula. We don't put the 200 into this formula. We just put, and I'll show you how we convert this in just a second, 200 into the formula times, and then we put the common ratio, which is 0.4, and then we just write this, copy this down, n minus 1. So anything not highlighted, we leave alone in the formula. And this is actually the formula. This is the actual explicit formula. And I'll show you how these work in a second. But those are two examples, or one example, of how to do the explicit formula and the recursive. Now this symbol here in the recursive formula, that whole thing, all that means is the word previous term. So what I'm going to play out, sorry, let me move that up now. So what I'm going to do now is this actually means the previous term. So we actually use numbers here, and we do use numbers, to find the next term in the sequence, okay? So the first term I got is 200. To find the second term in the sequence, okay? And all this means is I take the previous term, again, f times n minus 1. That would be 2 minus 1 is 1. That would be f of 1, which means the first term. So I take the previous term, so all this is previous term times 0.4. That's all this recursive formula says. So for the second term, I take the previous term, which is 200, and I multiply it times 0.4. So I take 200 times 0.4, and we already know what that is. It's 80. Oops, sorry here. So my next term is 80. Then to find the third term, I take my previous term, which is 80, and multiply it times 0.4. And when I do that, I know I'm going to get 32. So when you're reading recursive formulas for geometric sequences, the recursive formula, all this formula means is the next term in the sequence, next term, is equal to the previous term times the common ratio. So this is how I'd read it. The next term, f of n, this means next term. The next term is the previous term times the common ratio. To work out the explicit formula, I actually have to plug in what term I want. So let's say I want f of n. n equals 1. I want the first term. Well, watch. I know it's going to be 200, but watch. 200 times 0.4. Now I have to take n minus 1. And if n equals 1, then I take 1 minus 1, which equals 0. And so I have to put it to the 0 power. And anything to the 0 power is 1. So 0.4 to the 0 power equals 1. So 200 times 1 is equal to 200. We already knew that. But let's say I wanted to find the second term in the sequence. The second term, I take 200, again, just copying the formula, times 0.4. Now I know, now n equals 2. So now in my formula, n minus 1, so 2, I would write 2 minus 1 would equal 1. So now I have to multiply that times, or take it to the first power. Well, point anything to the first power is itself. So 200 times 0.4 to the first power is going to be 0.4, and we know that's going to give us 80. Okay, now going to the third term, f of 3. Now again, my n minus 1, I take 3 minus 1, which equals a 2. Now I have to square my 0.4. My f of 3 is going to be 200 times 0.4 times n minus 1. And since n is equal to 3, 3 minus 1 is 2. So now I square 0.4. And so when I square 0.4, I get 0.16. And 200 times 0.16 is equal to, you guessed it, 32. Now, what are the advantages of using this over this? Well, the recursive formula is, again, easy to say. You take the next term of the sequence is going to be the previous term times the common ratio. Well, you've got to know the term beforehand. In the explicit formula, I can find the 100th term without having to get the 4th term, 5th term, 6th term, 7th term, 8th term, 9th term, 10th term, 11th, 12th, and so on. So when I want the 17th term in the sequence, I just substitute 17 for n, and now that exponent now becomes 17 minus 1 is 16. Now I take that to the 16th power. So if I wanted to find, let's just find the 10th term in the sequence. I wanted to find the 10th one. Okay, so I take 200 times, again, my common ratio, and now because I have 10, my n minus 1 is going to be 9. 10 minus 1 is equal to 9. So now I have to take this to the 9th power. So taking my calculator, and I take 0.4, and I take it to the 9th power. It's going to be a pretty wicked decimal, right? And then multiply that times 200, and I'm going to get that. So my 10th term is going to be a really, really small number. By then, you've probably stopped bouncing on the bungee cord and are almost not going to be bouncing anymore if you're looking at that in context. So the recursive formula, you have to know the previous term. In order to get the next one. But in an explicit formula, you do not have to know the next term. You just have to know the formula. And you can figure out the 200th term if you want to by just plugging it into the formula. All right, now here's an excellent example from the book. We're going to write a recursive rule and an explicit rule for each geometric sequence. So go ahead and read this, and makers of Japanese swords, and look at the table down here when you're done reading, and go ahead and hit resume. Okay, the first thing we need to do is we need to find the common ratio. Again, to find the common ratio, you take the second term and divide it by the first term. 4 divided by 2 is 2, so we know that the common ratio is 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So we know the common ratio is 2. Okay, so here's the table. The number of folds, again, the first fold, second fold, third fold, fourth fold now creates those layers, and they're increasing exponentially. We know the terms, n equals 1, 2, 3, 4, 5, and so on. We've already identified the common ratio, and again, we get the common ratio by taking the second term, or term number 2, and dividing it by term number 1. Second term divided by first term, and in this case, it's 4 divided by 2, which equals 2. So we got our common ratio, and we looked at the table here, and we know our first term. Now, if we don't know our first term, then I would need to figure that out, and then we'd have to use logic to figure it out. So to write the recursive and explicit formulas, I need these two pieces of information. Okay? I need these two to write our formulas. So, looking at my notebook and I'm going to write my recursive formula. Now remember, recursive formula is very easy, but it's just a long way to write it. The first thing I need to do is identify my f of 1, my first term. My f of 1 is equal to 2. Then I recopy the entire formula in my step 2. I write it as such, f of n. That means the next term is equal to, again, say this, the previous term times the common ratio, which is 0.4 or 0.4, for all terms greater than or equal to 2. Why? Because we already know the first term, so I have to find the second term or above, because I already know the first term. So that's it. That's the recursive formula for that right there. And again, we say it, the first term is equal to 2, and the recursive formula, the next term is equal to the previous term times the common ratio. for every term above or equal to 2. Now, writing the explicit formula. Okay, for my explicit formula, we don't say my next term because I say whatever term this is, depending on what number I want. I take the first term. Now remember, substitute directly in. My first term is 2. And then I multiply it times my common ratio to the power of n minus 1. And that's the explicit formula. Again, the recursive, you need to know the previous term. Well, I already know the 5th fold, but what if I want to know the 10th fold? I got 10 folds. How many layers is that? The best thing to use is the explicit formula because you can just substitute the term that you want. I want to know the 10th term. That's 10 folds. All right? So all I have to do to figure out what the 10th term is, how many layers I'm going to have, is I substitute 10 in for n. So then I take the formula 2 times 2 to the n minus 1. And because 10 minus 1 is equal to 9, then now it's 2 to the 9th power. So at that point, I take my calculator and I take 2 to the 9th power, which is 512. And then I multiply that times my first term, and it gives me 1,024. So I know by the 10th fold, okay, the 10th fold, it's going to have 1,024 layers. And I can figure out what the 20th fold is, how many layers that creates. And again, the explicit formula is great for plugging in to find out the nth term, whether it's the 7th, the 8th, the 9th, or the 10th. But the recursive formula, you have to know the first one. So if I wanted to find the 10th one in this one, I'd have to find the second one, then the third one, then the 4th, then the 5th, then the 6th, then the 7th, then the 8th, then the 9th, then I could find the 10th. This one, I just need to know the formula, and I can jump straight to the 10th. Okay, let's try to solve a puzzle. Let's say we don't know what the first term is, and we got to figure out what the common ratio is. I know I wrote this in red and then it's smeared. Looks like it's bleeding. Sorry. My hands are clean. All right. So if we have two consecutive terms, remember how I told you to figure out the common ratio is going to be the second term divided by the first term. Well, let's say you don't have the first or the second term. Well, if you have two consecutive terms, you always take the biggest one, the one to the right, or, sorry, not the biggest one. You always take the next term divided by the previous term to find the common ratio. You don't do 135 over 405. You do 405 over 135. So you take the highest sequence term and divide it by the one previously before that. So now we take 405 and divide it by 135, and we have our common ratio of 3. So we know that this gets multiplied by 3 every time. Well, if I'm moving to the left, I'm technically dividing by 3. Now remember, our common ratio is going from 1 to 2 to 3, so it's going to be multiplying by 3. But to figure this out and create the puzzle, I need to divide by 3. So 135 divided by 3 is going to give me 45. And 45 divided by 3 is going to give me 15. And 15 divided by 3 is going to give me 5. Now I have my pieces of information. I've got r equals 3, and I have my f of 1, my first term, which equals 5. Once I have those, now I can write my formulas. And again, I'm going to write my recursive formula over here. My recursive formula, I just repeat. The f of 1 is equal to 5. Then I write the same thing all over. The next term is equal to the previous term times 3. 4 and greater than or equal to 2. And again, everything looks the same except for that number and that number. Everything else is the same except that number and that number. The recursive formula looks exactly alike. Okay, now I go to my explicit. My explicit formula, my whatever term I need to find is equal to the, again, f of 1 gives me the first term, 5, times the common ratio of 3 to the n minus 1. And that's my explicit formula. Again, what if I wanted to find the 10th term? So I want to find the 10th term over 6, 7, 8, 9. I want to skip above all those, so I don't need to use that. 405 times 3 times 3 times 3 times 3. I just plug this directly in. So again, multiply it times 5 times 3, and n minus 1, because I'm looking for the n is 10, 10 minus 1 is 9. Again, I'm going to do 3 to the 9th power, which is 19683 times 5, which gives me 98415. Now, if you use the previous one for the recursive, we do 405 times 3, then we get that. That's the 6th term. Times 3 would give us the 7th term. Times 3 would give us the 8th term. Times 3 would give us the 9th term. Times 3 would give us the 10th term. So you can do it either way, but the explicit is faster if you want to get there and just plug it in the formula. Okay, now let's do a real world example here in writing a recursive and an explicit formula. We've got a viral video going on. Go ahead and pause this video until you read that. And then once you're done, go ahead and hit resume. All right, now in this case, we know the 6th term and we know the 4th term. Now you can play with these numbers to find that 5th term here. And you could say 256 times 3, and then that times 3 is get it. No, then you say times 2, does that get it? Until you end up with 4. It's going to be 4, because 256 times 4, so 256 times 4 is equal to 1024, and you multiply that times 4 again, it's 4096. So you can use a guess and check method. But let's say the numbers were not this obvious, and you wanted to figure out what the common ratio was. Well, the common ratio, okay, which we've got... our n, stand by. Okay, you have to use logic here. So my 6th term is equal to 4096. My 4th term is equal to 256. So I know that my 6th term is equal to my 5th term times r, right? Because that's my recursive formula, right? The next term is equal to the previous term, just times the common ratio. Well, I also know that n5 is equal to the previous term times that. So now I know that n6 is equal to n5 times the ratio, n5 is equal to n4 times that ratio, and so now I just use basic substitution. So I'm going to substitute this in for n5 above here. So I'm going to rewrite this formula now for n6. So my 6th term is equal to, again, I'm substituting this in for n5. I'm just going to write n4 times r, and then I bring this r down here, times r. Now, I've got a formula here that has two numbers that I already know, right? And I know that r and r is r squared. So I know that n6 is 4096, and I know that n4 is 256, the 4th term, times r is r squared. So now all I have to do is solve for the variable. I take 4096 and I divide both sides by 256, which equals 16, is equal to r squared. And then I take the square root of both sides, square root of r squared, and the square root of 16, which gives me r equals plus or minus 4, and in this it's going to be positive 4, and I can double check it's not negative 4 because I'm not changing these negative positives, although it could, but we've got our r is equal to 4, excuse me. I just do need to make the definition of a positive square root we're using here, and we'll double check in here. If this was negative and I multiply it by negative 4, we could still get that these could be negative. But in this case, we know that we can't have negative responses for our viral video, so we're going to throw out all the negative responses because this is a real world example. So now I know my common ratio, which is 4. R equals 4. That's my first piece of information. Well, now I can plug in the recursive formula and do this, or I could just divide 4096 by 4. And dividing it by 4, which I told you before, is going to give us 1024. And then we could work our way backwards and get all of these if you wish. Or you could just plug it into the explicit rule and get just the first term if you wanted. Because again, we're going to find the, we found it, but we need to find and write the rules. So really we only need the first one. So you can plug that into just the general explicit rule, which is f of n is equal to the first term, which we do not know, right? But we know the common ratio, and we know 6, right? So we want to find f of 6, and we do know f of 6. Or let's use f of 4, sorry. Let's use f of 4 is equal to the first term, which we don't know, times the common ratio, right? Common ratio, which is 4, times n minus 1. Now, my n is 4, my 4 minus 1 is 3. So now I've got 4 cubed. Okay, now I need to substitute everything in here that I do not know. F of 4, or that I do know, f of 4 is equal to 256. I know that's equal to that. And 4 cubed, 4 times 4 times 4 is going to be equal to 64. So then we have 64, whoops, 64x. Divide both sides by 64. And this would actually be n instead of x. X is going to equal 4. 256 divided by 64 is equal to 4. So now I know my first term, f of 1, is equal to 4. And my common ratio is 4. So now I need to write my recursive and explicit rules. And again, here's the explicit. I'm sorry. I was going to do the recursive in green. And then my recursive. So let's write the recursive first. Again, everything's the same. F of 1 is equal to 4. And then I say the previous term, or I'm sorry, the next term is equal to the previous term times the common ratio for every value of n greater than or equal to 2. Okay, the explicit formula now is going to be f of n. My nth term is going to be equal to my first term times the common ratio, which is n minus 1. And that's it.